Hey guys, EST here, and you've probably wondered this as much as I have. How many nuclear bomb detonations would it take to completely destroy the environment? And the answer is definitely going to surprise you. I mean, I hate to kind of ruin the ending, but we're still not entirely sure. But with computer models just in the last 5 years, we've determined that pretty much everything you know prior to that is not quite accurate. So if you watch this video to the end, you're going to be as fascinated as I was. I thought this will just be like oh, haha, funny short little 3-minute video about, oh, it's this many, and wouldn't that be bad? Oh boy, dark humor, we're all in trouble. But this rabbit hole gets deep, and it is absolutely fascinating. So the big thing is nuclear winter. It's where lighting off some amount of nukes would cause something to happen to sunlight and the atmosphere, and then the whole world would drop, X amount of degrees, and then nothing could grow. And if nothing grows, anything that eats plants dies, and so there's no food supply. So I think that was proposed in 1982, and it was pretty much believed by people since then. Now, the idea doesn't come from nowhere. It comes from volcanic eruptions, because in recent recorded history, the last 200-300 years, and then what we can find out from trees in the last couple hundred to couple thousand years, there were some serious volcanoes that did some serious damage. And a volcanic eruption, not just some little, molten lava spewing out, but an actual explosion, like Mount St. Helens kaboom. It's somewhat similar to the amount of energy in a nuke. Now remember, when I say a nuke, that is not a standard unit of measure either. They are drastically different in size. They go from 10, 15, 20, 50 kilotons, which, Hiroshima was 15. And that's kilotons of energy worth of TNT exploding all at once. To the Tsar Bomba, which was 50 megatons, because they thought 100 might be too big. So 15,000 tons to 50 million tons. But as it turns out, almost no number of sheer nuclear blasts by themselves, like the actual detonation, would really do anything. What are they worried about? Well, it goes back to the volcano thing. It's ash and soot and particles and dust and whatever else fired up into the atmosphere. Well, that's what they were initially wondering about because, nuclear winter. Its explosion equals soot equals blocking out the sunlight, and then it gets up too high that it doesn't come down very easily. That is the super, super quick version of how it works. So we've seen particles of sand from really big storms and deserts and abnormally dry times and that kind of stuff apparently get up into the atmosphere where they can create more surfaces for ice to form where ice would not normally form. Now, in some cases, you can have liquid water at negative 35 Celsius up in the air because it doesn't have anything to cling onto to form an ice crystal and it can't do it spontaneously. And then there's also air pressure and that kind of stuff, so there's more factors, but still. Now that can disrupt weather, for lack of a better term, by putting clouds in the wrong place. They would form too early instead of over mountains and that kind of stuff. But we've never seen that sort of thing completely ruin the entire world's climate. Arguably, except for the theory about the dinosaurs and the meteorite, and they think that was just straight up dust. Turns out if you hit it hard enough with enough mass, it'll put some stuff into the air. Who would have thought? So with most volcanoes, the ash falls out of the air within days to weeks, so the long-term effects are negligible. But of course, I'm talking about the ash. The actually worst part is the droplets of sulfuric acid that can block sunlight. And they could stay up there for a bit, but they tend to just drop down in acid rain, and that's that. But if they get up into the stratosphere and interact with hydroxide and water to become H2SO4, they last several years. Then you get these weird interactions with air temperatures to sea ice, and you get this feedback loop that lasts a lot of years. Not Ice Age long, but 10 plus. So volcanoes can't put ash high enough into the air. It falls down too quickly, gets caught, and other various reasons, not enough energy, etc. But the sulfur compounds are what we're worried about. Now, you don't get sulfur compounds from a nuclear blast. Well, I suppose unless you nuked a volcano, but, why would you do that? But let's talk about the biggies that we were actually able to determine had an effect. 1991 to 1993, Mount Pinatubo. It was a global drop of about 0.5 Kelvin, which is basically just Celsius, but with a different starting point, but the units are the same size. So 0.5 might not sound that high, but it is. When it's everywhere, you start getting weird wind patterns and all that, so it was noticeable. And like I said, 91 to 93, it didn't keep erupting that whole time. 1815 was the worst that we have in, really recorded history. The effects from the 1815 eruption lasted until 1820, and it did help that there was an earlier mystery eruption, we're not sure which one it was, in 1808. But the 1815 one was Mount Tambora. If you want to learn more about it, it was called The Year Without a Summer. And that was not just, oh, it's a little nippy and I gotta throw on a jacket at night in June. It was considered the last great agricultural disaster in modern times. And we're not just talking regional like the Irish potato blight, we're talking like worldwide. So while the global averages only dropped 0.4 to 0.7 Celsius, which is, in the range of the last one, which is, barely 1 Fahrenheit, some parts of Central Europe were negative 3.5. That is a lot. And remember, it's not just colder because plants can do okay with a little bit of a shift. It was the lack of sunlight getting to the vegetation. That's a 1-2 punch right there when you consider both. So without this becoming the volcano video, I just wanted to tell people how bad it got, and to summarize this event, it got really bad. Just Google the year without a summer if you want to find out more about it. So Mount St. Helens, let's circle back to that one. It didn't really get anything high enough in the air. I mean, that's like the short version. So no significant effects. I mean, right downwind of it, I think something dropped like 17 degrees Fahrenheit or something they said, which yeah. But it all fell down and some stuff was coated in ash and, 250 miles down a city was looking pretty bad. Look up the photos, but it wasn't worldwide and there was just nothing persistent from it. And if you look at the photos, that's a big boom. That is a lot of tons of ash and debris in the air. So I keep talking about ashes, and then we find out that that's still not really a thing. It's really the acids and the sulfur compounds. What about nukes? What do they do with ash? Do they just incinerate stuff, then the ash is like fallout and it goes really high? Weirdly, no. It's from the resulting firestorms, and firestorms are a very specific thing. So what do we have that's close to this? Well, the 1991 Kuwait oil field fires, which actually kind of debunked this theory, unfortunately. People were real quiet about this for about 10 years after it, because the scale of it was somewhat similar, and, well, we're still here. So after Iraq was like, hey, you're drilling across the border diagonally. That's rude, and we like oil. And Kuwait's like, no, we're not. So Iraq invaded them, and then we're like, hey, we like oil stability. So then we went over and, bashed them back. That was the first Gulf War. So on the way out, they're like, fine. If you're going to have your allies come and be like, well, we don't like Saddam because he's a dick, and I don't know, Kuwait's friendlier with us or something is already allies, well, then we're just going to burn your oil supply. So on the way out, they set tons of the oil fields, the oil lakes, or oil storage, everything. If it started with oil, they lit it on fire. And because of the ongoing war, they couldn't just get firefighters out there. Plus, it's really hard to put out. So it burned for 10 months, 1.5 million barrels of crude. The fumes and the chemicals, because, like I said, it's crude, it's not purified, it's not distilled. Who knows what's in there? Oh my gosh, it polluted everything. It contributed to Gulf War syndrome, which is a multi-cause thing. Not going to go way into that, but it was multiple things. So the fires, the soot, the material, it rose about 5 miles, but then it was absorbed by the clouds and rained down pretty quickly. So the whole thing is, does it get to the stratosphere? If it does, that's where it stays. So what we need is for soot to not get into the stratosphere. We already found out that volcanoes can't get ash that high, but they can get lighter compounds that high. Well, the stratosphere is 12 plus miles up. That's where it starts, is 12 miles up. Keep that number in mind. But yeah, all the ash and material and soot and hazardous chemicals and everything pretty much got rained down in clouds because they're absorbed by clouds, and that's the end of that. They don't keep rising. So that was a real-world test that threw all these theories completely out the door. So nukes are hot, and cities have things to light on fire. But we're not talking about the big flash cooking explosion, we're talking about the resulting fires afterwards. Well, the blast in Hiroshima, generally the material only went up 6 kilometers. Not even 6 miles, 6 kilometers. So a lot less than 12 to get to the stratosphere. But that was a really weak bomb. In fact, let me just direct quote the study. Within a few minutes, it then dissipated due to the winds, which the individual fires within the city took almost 3 hours to form into what they call a firestorm and produce a pyrocumulus cloud. That is when it is considered a firestorm, is when that happens. A cloud that is assumed to have reached the upper tropospheric heights, but still not the stratosphere. As over multiple hours of burning, the firestorm released an estimated 1,000 times more energy than the bomb itself. I mean, it may be a little bit of fuel, but when you split an atom, there's a lot of energy there. But when you take that much wood plus other things and light them all on fire with a big flash ignition, you're gonna get some energy. So that's real-world examples. What have we done since then? Well, around the mid to late 2000s, there were a whole bunch of studies and books, and scientists got really interested in it again all of a sudden. If soot did get to the stratosphere, or could it get there, how long would it take? And 10 years seems to still be about the agreed upon number, even with more modern computer models. So that's why we need it to not get there, because we're talking 1 to 4 weeks to drop out of not the stratosphere. But once it gets to the stratosphere, it is staying there. So there's a very famous study and some math done by Michael Mills in 2008. It's one of like 2 or 3 really major studies, and it was later corrected in multiple different directions. Computers weren't that great back then, but they are now. So they projected a 50 Hiroshima-sized bomb, so very small, in a, quote, regional conflict in non-tropical areas. So something far away from the equator one way or another. And the general finding was that 50 of them, really small bombs, which would be like tactical warheads on up to really inefficient stuff smaller than we use today, could disrupt whole portions of the globe's agriculture. So the theory was nitrous oxides from the detonations themselves could deplete the ozone layer, because remember, we weren't aware of that this whole time. Now that would cause worldwide ultraviolet radiation to get through, and that's really bad for humans and really bad for agriculture. Yes, in my part of America, we say bag and agriculture, and just get over it. I'm not going to say agriculture, that's just stupid. So the resulting calculations were 70% ozone loss. That would be really bad. Now it gets worse. There was another theory called a nuclear summer, where if you thought, okay, people just stick it out for 10 years, the tough people just, get her done. The world certainly has a lower population after that, but, we could move on as a species. Stronger, better, and a lot less of us, probably not necessarily the absolute worst thing, if you don't mind, X amount of percent of people on Earth dying. Personally, I don't agree with that. I see the cold, hard logic to it, but that's not how we do things. You don't just say, hey, what would it to help the homeless problem? Let's just run around and kill them. Look at that, problem solved, perfect math, let's do it. But what is nuclear summer? Well, if there was a nuclear winter for 10 years, the soot drops out of the stratosphere, but since everything froze, everything was like, the North Pole on down to just about Texas, everything green, every animal, everything biological died or went significantly dormant, but it froze, which preserved it. Now you've got the CO2 from everything burning, then you've got the methane from everything rotting after thawing, all at once, and then you've got way less green stuff to help turn CO2 into oxygen. It would be the greenhouse effect on steroids. It would be absolutely insane. So even though the human species could survive nuclear winter, the resulting nuclear summer, which people really don't even say that it wouldn't happen. They ran the numbers and they're like, oh yeah. I honestly couldn't find one person contesting it. So yeah, if you're just gonna, hunker down, hope you like it warm, I would move to northern Canada. Like right when the stuff starts thawing out and stinking, you know what I mean? So modern checking with supercomputers and more budget, more processing, better numbers, better math, better everything, confirmed that 100 firestorms would do it. They're not entirely sure about 50, but for sure 100 would. Now, all nukes going off at once, every nuke that we have on the entire planet, they estimate would put 150 teragrams, which is like a kilogram but a trillion instead of 1,000, of soot into the atmosphere. Now, once again, would it or would it not get to the stratosphere? That is very heavily debated, and we just don't know. Real-world examples say no, with a couple hinting at yes, but we're not sure because nothing like that has happened in recorded history. So, 150 teragrams of soot would be -8 Celsius for 10 plus years. Remember, lots of people starved at -1, and in Europe 3.5. 3.5 was labeled as, hey, summer didn't happen. -8 would be like, what is summer? I've never heard of that. Now that would result in a global drop in rainfall, which was another thing that wasn't established in earlier studies. They kind of confirmed that ish in 2014, actually. So everything they found would be, if it got there, it would be way worse than we thought. Like everything was 10% worse or worse. Now, wacky weather from La Nina and El Nino and wacky weather from volcanic activity, we have seen that. It's like the wind does this thing to the ice, which does this thing to the atmosphere, which does this thing to the jet stream, and it all just kind of does stuff. So it doesn't take much to disrupt weather, that's for sure. So that was part of the, we've got better weather models now, we've got more money thrown at it, more supercomputer clusters, and generally it's just, it would get really rough for a lot of people. Countries without good infrastructure would just be wiped out. It would just be absolute chaos. So even a really light version of this, we're talking right on the verge of what they think might cause it, really low numbers of nuclear exchanges, just in a regional conflict, not a world war. If the ash and material got up to the stratosphere, it would be devastating. And like I said, for more reasons than we thought earlier, it actually got worse. But then there was the 2018 Los Alamos National Laboratory study. They determined that a regional nuclear conflict would not result in any sort of winter effect. Unlike previous studies, the study simulated the process whereby black carbon will be lofted into the atmosphere and found that very little would be lofted into the stratosphere. So there's your final answer on that, because remember, that was the number one determining factor this entire video, with a couple exceptions. So as a result, the long-term climate impacts were much lower than the studies that came before it. And this was kind of a revised version of an initial study. They took their work and kind of checked it. So they weren't starting from zero, and they didn't have like some kind of alleged bias. So a direct quote from the study is, "The probability of significant global cooling from a limited exchange scenario as envisioned in previous studies is highly unlikely." And of course, the study they were working off of was in 2007. So it's not like 1980s where they barely even had computers and didn't know what they were talking about. Fast forward a year to 2019. Actually, it looks like the black carbon increases 10 times its normal size. I assume they mean like molecule bonding distance or something. I don't know. You can't change the size of atoms. I tried to figure out what they meant by that, but whatever. Maybe they just wrote size and meant density. I don't know. Doesn't make sense. But they said it would increase to 10 times its normal size if it reaches the stratosphere. But then another part of this revised study said that would help it reach the stratosphere. It almost seemed to contradict itself. This was a very odd study, not well documented for being, 4 years ago. Then they found the amount of ozone depletion would actually be worse, much, much, much worse, for other various reasons, and then it would have even worse rainfall reductions than previous studies. So we've got some studies saying if every nuke was lit off at once, all over the world strategically, it probably still wouldn't ruin the environment. I mean, you've got radioactivity, but people like to confuse meltdowns of nuclear power plants where it's just fuel sitting there to the fuel detonated, that's the point. Nuclear bombs don't really leave that much radiation. So people are like, oh, but nuclear power plant, you still can't go to Chernobyl, it'll still kill you. Yeah, fuel rods. Yes, don't look at, touch, or lick the corium. But in a bomb, it goes kaboom, there's a big thing, and then there's not much for unspent fuel. They're actually quite efficient. So you want to stay away from like the fallout, cesium? But the stuff that's really, really dangerous only sticks around for like days, 2 weeks, and that's it. Then you can come out. So nuclear meltdowns and nuclear bombs are not the same thing. It's not, oh no, a nuclear bomb went off. Now we can't live there for 200 years. That is just not the case. So if you're thinking, hey, he hasn't mentioned radiation. Well, now I did, and it's because it just has no place in these calculations, really. So we've got like over even just a span of 3 years, very, very contradictory studies. And it just comes down to we're still not entirely sure if the soot would get there. In 2021, they had a follow-up study that found out the ocean currents would be messed up more than we think if even 5 teragrams of soot was put into the stratosphere. They nicknamed it a nuclear Nino. So it's like El Nino, but nuclear. And that's like that whole, hey, we're discovering new ways that this would be worse, but we're still not sure if it would happen. I will say in the worst scenarios where they're like, okay, we don't know if it'll get there or not, let's say it gets there. 150 teragrams into the stratosphere, 5 billion plus dead, I think like 90% of agricultural output removed from the earth. Yeah, it would be bad. But the lowest number I could find that people were like, this would probably do it, is one small area, not widespread, 50 firestorms. Now, the only way to light 50 firestorms is to have an insane drought and just have natural causes. I should probably mention that the nuke almost isn't even a thing. It's just a really, really good match. These last 2 months, Canada has been on fire, and it was because it was unnaturally dry for a bit, and then a bunch of fires lit. And now they're blowing this way. Once the winds picked up, they just started showing up on radars, and there they all are. And the smoke is burning my eyes and my throat and my nose, and there's good days and bad days, but my gosh, it is unbelievable. Now, those aren't considered firestorms necessarily, but you gotta wonder with that much area, and like all the Californian wildfires and all that stuff, like, is that comparable? And everybody just keeps saying, no, the closest we had was the Kuwait oil fires, but I couldn't find, like, volumetric calculations or thermal output comparisons or just anything, which is weird. You'd think I'd be able to. If you guys could find anything about that, I researched that for longer than this entire video because I just wanted to know. I'm thinking, well, there's got to be 50 fires going on right now in Quebec. You know, what would you consider to be a firestorm? Like, what classifies? And all the studies pointed out, it doesn't have to be nukes. Nukes would just light the firestorms. It's the firestorms that will do the ash because the nukes won't do anything. Not directly or immediately to the atmosphere. Don't believe me? Oh, I kept this one since the beginning of the video. The Tsar Bomba, the biggest bomb ever detonated 50 megatons. Stratosphere starts at 12 miles. The mushroom cloud from this was 37 miles high. You could see the flash from 620 miles away. And if you were standing out looking at it, you would get third-degree burns at 62 miles away. And remember, it's an energy dissipation radially, which is similar to kind of like exponential. So like if you're 10 feet away, it's this hot, and if you're 20 feet away, it's not half the heat, it's less than half the heat, like significantly less. So if you're 62 miles away and you can still like burn a human, that's a lot of energy. Well, the atmosphere and the ozone are still here, and whatever dust was thrown up in the mushroom cloud or whatever wasn't enough to do anything. So that's why they're so focused on, well, nuke equals firestorm equals this equals that, and then it would have to kind of blow, but then the nuke wouldn't lift it, and it seems a little far-fetched to me, and that's why people are saying, well, nuclear winter is completely false. But there were a couple, like I said, really, last couple years modern studies that have said it's possible, because nobody studied how black carbon soot would actually rise. But then why didn't it do it from other more mundane fires? What's so special about a nuke? And the answer is nothing. So the opposing sides, if I were to just kind of bullet point what they were saying, saying this is unrealistic or would never happen. The number one thing, can it even get to the stratosphere in the first place? Is just heavily debated. I think I kind of already covered that, but this is a 5 bullet points that I should probably, for fairness, read. How much light would the soot actually reflect or absorb? How black would it be? How dense would it be? We don't know. Maybe it would get up there and it wouldn't block anywhere near the level of light that we think it would. But still a few percentage can throw everything off, you know what I mean? But the thermal output of the sun goes up and down based on, 14-year cycles approximately? And even that doesn't do that much as far as dynamic weather. It does next to nothing, actually. How quickly would the black rain, as they call it, wipe it out? Would it get absorbed by the clouds? Would it even get there? And how long would it stay in the stratosphere? We don't know. The only thing that was up in the stratosphere causing year after year issues was volcanic, not hydrochloric acid, sulfuric acid, and sulfur compounds, which do not result from fires or nukes. And then to back up even further, would cities even firestorm universally, or would some of them go out? Would they all just instantly be on fire? Would there even be enough oxygen? We don't know. We know that Hiroshima burned pretty good, but we also know 15 kilotons, I think it was 1% efficient, not anywhere near the amount of fuel that they thought would actually, not combusted, broke down. It's not fused and it's not fizzed. I feel like I should know that. Split. There you go. Split. How about that? I don't know why I can't think of the word. Let's go back to fizzed. I like that. It didn't fizzed. No fizzing. Not enough fizzing. So nuclear bombs that we have now that are on ICBMs, which actually have to by weight be smaller than a 50 megaton, so don't worry about that, they are hotter. And most cities are surrounded by trees at some point after some amount of miles. So if you're going to say, oh, concrete doesn't burn and New York City barely has any trees, yeah. But they're still not sure if a nuke would for sure they would for sure cause fires, but would they for sure cause firestorms that result in 50 plus separate pyrocumulo something nimbus? I don't remember the term. That's debated. What isn't debated is that it would almost be impossible for it to happen during winter. In fact, a lot of people pointed out, you do realize that late spring to early summer was the time that everybody chose for their experiments and their numbers and their basis, because it's the hottest and it's the driest and it's the easiest for the fires to start. If it already was winter, that's a lot of snow. That's a lot of thermal energy. That's just, you could dissipate some stuff. You could melt some snow. You'd have the water. Wet trees coated in snow just do not light on fire. Doesn't matter how many nukes you fire at them. The amount of energy it takes to transfer that much, or to, I should say, phase change that much solid water into a liquid and then into steam, quite simply, it could soak up a nuke. So time of year is important. All kinds of conditions are important. It's becoming less and less and less likely. So to me, I find it possible, but a lot less likely than you probably grew up learning in school, which is, oh, nukes equal nuclear winter. Nobody would ever light them off because nuclear winter, everybody dies. Nobody should ever have more than 100 nukes, because if you fire more than 100 nukes, you'll result in X amount of fires and X amount back at you, and then the amount of damage done back to you would destroy yourself, so you'd just be taking out everyone with you. And there are some people crazy enough to do that, but it's not most. And crazy cults, religious groups, terrorists, they just aren't going to get a hold of enough of them and be able to launch them in enough locations. That is like basically strategically impossible. But I hate to rehash my old video and I hate to flip everything on on its head at the end of this video, but one nuke would destroy the entire environment worldwide. If you want to know why, go watch my other video recently about why the worst type of disaster with the worst amount of deaths would be the type where initially nobody dies. Something just economic or energy related would result in the most deaths worldwide compared to almost anything else. Alien invasion, zombies, plagues, all-out war that kills 1 billion people, that would be bad. But the worst, most devastating thing environmentally that would ruin the entire Earth permanently would be some kind of thing where everybody's still alive, but everything breaks down. That sounds counterintuitive, and I will warn you, it will absolutely ruin your day, your month, and your year if you go watch that video. It is a big downer, but it's the truth. People just don't want to talk about it because it is somewhat of a recent discovery, unfortunately. So if you want to ruin your day, go watch that. Otherwise, I mean, I've got less depressing, dark videos on this channel, almost all of them. I mean, want to learn how to back up and store your data for really cheap, everything proof it? I got a video on that. Tons of stuff about solar, everything's about dirt cheap and nothing sponsored. Except for one sponsored video, but still, they're awesome. So go check out the rest of my content. Watch for another really cool one coming up about how to protect your garden from pests if you don't have any kind of resources, and I'll see you guys next time.